Hello, so in this video we're going to look at finding functions and we kind of already did that already in the earlier parts of this chapter. So for example, if we have the derivative, say dy dx, let's say that's x squared, right? Then we integrated to get back to the original function y, right? So we integrate, and so with the integration we said we added 1 to the power, so we do x, and then 2 add 1 is 3, then we divide by the power, so we have a third x cubed, right? And we also said that we have to always add on a plus c, a constant, because if we were to go the other way to differentiate, well, if we differentiate a constant, say if it was plus 1, that goes to 0, okay? Same in plus 2, if we had a plus 3, any constant whatsoever on the end, because there's no x, it will go to 0 after we differentiate. We saw that in differentiation, right? And so we always have to add on this plus c. So this is finding the function, but what we're going to look at in this section really is how to deal with this plus c, okay? Because at the moment it is kind of a bit vague because we don't exactly know what the actual number is. So we could have actually infinitely many possible possibilities, because we could have infinitely many possible numbers we can choose here. And so we need some information to find the c in my function for y, okay? And usually we're going to need to what we're going to look at is trying to find a point on the curve on the equation to substitute into to get this c, and so then we can find the precise answer for what y is, right? So the precise number for c. So we're going to look at some examples then. So let's have a look at some examples to illustrate what I mean. So we have this example. We are told the curve C with equation y is f of x passes through the point 45. We're given that the derivative f dash of x is equal to x squared minus 2 over root x. We need to find the equation for C, so we need to find f of x, right? But we got f dash of x, the derivative. So to get to f of x, we're going to need to integrate, right? So we need to integrate this expression, but we need to, it's not just in powers of x that I can easily integrate. I need to use power laws and to split stuff up to simplify to be able to get it as powers, okay? So let's split this fraction up first. So I can say well, x, I can split that up to x squared over root x minus 2 over root x, right? And what can I do next? Well, I want to write everything in powers of x. So root x goes to x to the half. So it'd be x squared over x to the half minus 2 over x to the half. Okay, now, if you spot, I have x's on top and bottom. If I'm dividing the same number, I need to subtract the powers. That's my index law. So I'm going to do x then to power of 2 take away half if I subtract the powers. 2 take away half is 3 over 2. There we are. Then we have minus 2, and then this x to the half is a denominator. It's a fraction. So I can make it x to the minus a half there, okay? Now I can integrate this, okay? So now f of x then, if I integrate these powers of x, well, firstly, we're going to x to the 3 over 2. So we're going to add 1 to the power. Well, 3 over 2 add 1 is 5 over 2. Then we're going to divide. So divide by 5 over 2. Then we're going to subtract 2. Then we integrate x to the minus a half here. Well, again, we add 1 to the power. Minus a half add 1 is positive a half. Divide by a half. Okay. And then we have a plus c on the end. And so then we can just simplify, right, these fractions. So we're dividing by 5 over 2. We can basically flip the fraction to 2/5 of x to the 5 over 2. Then we subtract, well, then we do 2 divided by half, right, because we've got 2 on the top and then a half on the bottom of the fraction. So 2 divided by a half is 4, so minus 4 x to the half, add c. And that's my function, okay? But I need to work out what this plus c is, right? Okay. So what we're given here, it passes through the 0.45. We have a point on this function. So what I can do is substitute that in. So I'm going to sub in 45 into f of x. Okay, so that means x is 4. So if I substitute x is 4 into my function here, I'm going to get 2/5 of 4 to the 5 over 2 minus 4 lots of 4 to the 5 to a half, add my c, and so then I can just put that in the calculator. Well, 2/5 of 4 to the 5 over 2 minus 4 lots of 4 to the half gets me 24 over 5, add c. And so the y value is 5, so this has to equal 5. So therefore 24 over 5 add c equals 5. Then I can subtract 24 over 5 to both sides to get c. So if I do 5 take away 24 over 5, I get c to be a fifth. So therefore my final answer for f of x is going to be 2/5 x to the 5 over 2 minus 4x to the half, add c, which is now a fifth. And so that's the idea, right? When we got information, if we got a point or some values we can substitute into, we can find this c, okay, to get the full precise answer for my function. Okay, so let's have a look at this example. So now we got dy dx is 3x to the minus a half minus 2x root x. Okay, and we're given that when y is 10, x is 4, that's going to be my value, so I can substitute into, but we'll get to that point. We need to find y in terms of x. Okay, so it says find y. What have we got here? Dy dx. We've got the derivative. To get to y, the original function, we need to integrate, right? So we're going to integrate this expression, but at the moment this x through x is causing a problem. It's not just as a power of x right on its own. So I'm going to need to clean that up. Well, this x through x, right? 3x to the minus a half, and then minus 2x. Root x is x to the half, right? What can I do now? Well, I have 3x to the minus a half, then minus 2. Then I can, I'm basically what I'm doing here is I'm multiplying x by x to the half. X has a hidden power of 1. So that means I'm doing x times x to the half. I add the powers. So x to the 1 add a half is x to the 3 over 2. Okay, that's my index laws. And now I can integrate, right? So therefore y, the original function, if I integrate, I firstly integrate x to the minus a half. We're going to have x, if we add 1 to the power, minus a half add 1 is positive a half, then divide by a half. Then minus 2x, well then we integrate x to the 3 over 2. So if we add 1 to the power, we get 5 over 2, and divide then by 5 over 2, and a plus c on the end. Okay, let me just tidy up the fractions. So y would be, well, here we're doing 3 divided by half, that will be 6. 6x to the half. Then we're doing minus 2 divided by 5 over 2. Right, so if I compute that, minus 2 divided by 5 over 2, we get minus 4/5. X to the 5 over 2. And plus c. Okay, so we've got this y, we've got the expression for y. Okay, but now we're given this information as well. When y is 10, x is 4, okay? So when x is 4, y is 10. That is information I can substitute into here, my function y, to get find c, right? So if I substitute that in, so therefore y is 10. So 10 for y is going to be 6x, where x is 4 to the half, minus 4/5 of x, which is 4 again, to the 5 over 2, add c. Okay, now I can just simplify some stuff. So 10 equals, if I do that in a calculator, okay, I get minus 68 over 5 add c. Okay, so all this boils down to minus 68 over 5. Okay, so then to find c, I can just I can just add 68 over 5 to both sides. So c is 10 add 68 over 5. And so I get 118 over 5. So therefore, finally, y now is 6x to the half minus 4/5 x to the 5 over 2, add c, which is 818 over 5. Okay, there we are. So now we've got the full, the precise answer for the function y there. Okay. Okay, cool. Okay, so we've got this question now. Slightly more interesting. So we've got the height of an arrow fired horizontally from the top of a castle modelled by the function f of t, where f of 0 is 35, given that f dash of t is minus 9.82. We first need to find f of x. Okay. So really, without even trying to bother or be bogged down by what's going on, we should know that if we got the gradient f dash of t, to find f of t, we just need to integrate, right? That's all we need to do at the moment. So if we integrate the derivative to get the original function, well, minus 9.8t, when that integrates, so we're going to get minus 9.8t. Okay, well, t is on its own is just a power of 1. So if we add 1 to the power, we get 2. Then we divide by 2. So t squared over 2. Okay, cool. Then we add a plus c. Okay. And then I can simplify this a little bit. But minus 9.8 divided by 2 is minus 4.9. T squared add c. Okay, cool. Can I find c? Yes, I can. Because I've got this information here. I've got f of 0 is 35. So f of 0, firstly, well, that means x is 0. I'm plugging into my function. So when we've got t is 0. So when t is 0 into here, I'm going to get minus 4.9 lots of 0 squared add c. Well, that just goes to c, right? Because this whole thing goes to 0. And then I'm told that f of 0 is 35. So that means c has to equal 35 here. Cool. So therefore, then, a function of t in final form is minus 4.9 t squared add c, which is 35. There we are. We found f of t. Cool, that's part A. Part B, we need to write down the height of the castle. We need to determine the height of the arrow when t is 1.5. Okay, so what's basically going on here? You would have seen this when we did quadratic modelling in chapter 2. Very, very similar example we looked at with something being fired in the air. The idea is an arrow is fired from the top of a castle. So if you imagine we're on some platform above ground, so say that's the ground level, right? The ground. Basically, we start from the castle, which obviously is some meters above the ground, like has a height of h above the ground. Then an arrow is being fired in this sort of way, and then eventually it hits the ground. Okay, that's the whole idea. Okay, and it will look like a quadratic curve, right? And that makes sense because we've got a quadratic function here. Okay, so that's described in the trajectory of the arrow at time t seconds, right? Okay, so with that in mind, we need to determine the height of the arrow when t is 1.5. So if I remind you, f of t is minus 4.9 t squared at what was it? At 35. So the height of the arrow when t is 1.5, we just substitute that in then. So substitute t is 1.5. So at t is 1.5, the function at 1.5 is going to be minus 4.9 of 1.5 all squared, add 35. If I just put that in the calculator, I get I get 23.975. Does it give any units? Meters. Okay, meters. The M. Okay, cool. Right, okay, so that's it. Part C, we now need to write down the height of the castle according to the model. Now, another exam tip, write down means you shouldn't really need to compute anything. No working out's required. You almost can just look at something and then you should be able to deduce the answer. Okay, so write down the height of the castle. So, it's this here. Well, we're starting at the castle, right? We're starting at the castle. So that means we need to find the height when t is 0, right? Because that's the initial height. We're starting at the castle. So initially, we're at the castle. So when t is 0, f of 0 is going to be minus 4.9t. So minus 4.9 of 0 squared at 35, which is just 35, okay? So that's my height. Cool. And you could have just spotted that, right? Like I said, if you write it down, you could have just spotted that when t is 0, we get 35, and that's from here. Okay. So when t is 0, we get 35. But there we are. Okay, that's the whole idea. We start at the castle initially when t is 0, and that's my height. Okay. Part D, we need to estimate the time it would take the arrow to hit the ground. So again, if we go back to my sort of drawing here. Eventually it's going to hit the ground, okay? And that ground level is when the height is 0, okay? So we need to basically say f of t equals 0. That's my height. So if I set that to 0, my function, that means minus 4.9t squared add 35 equals 0, right? My function equals 0, okay? When it hits the ground. Cool. So then I need to solve for t. So that means 4.9t squared equals 35. So t squared, if I divide by 4.9, I get 50 over 7. So therefore t is going to be plus or minus root of this. Right, so plus or minus 5 root 14 over 7. That's what my calculator gets me. Okay. So as a decimal, that would either be t equals 2.67 or t would be, if I do the minus of that, minus 2.67, right? To 2 decimal places. Okay, so which value of t do we pick? Well, time, t's time, right? So that means it has to be positive, right? Time is positive, so t is positive. So we can only take the positive solution. So t is 2.67 to 2 decimal places. Does it say the units? I don't think it did it? The height in meters. No, it just says t. Okay. Weird. I just leave it as that then. There's no units apparently. So there we are. T is 2.67. Okay, part E. So that's just finding the root essentially. So that would be 2.67 there. Okay, when it hits the ground in time. Okay, part A, we need to state one assumption using in my calculation. Again, you do get these questions, and a very good assumption I like to give in these questions that works a lot of the time. It's the whole idea about the ground, right? So the ground has to be completely flat for us to have this function here, but in reality, the ground wouldn't be completely entirely flat the whole way through. It'd be slightly steep or a bit hilly at certain ends, right? It could be something like that, right? With some humps, because the ground level never is completely flat. It's all it'd be a bit inclined, right? Which would affect my model, okay? As we would have to adjust my equations, okay, and incorporate some extra stuff. So that would basically be my assumption. The assumption is the ground is completely flat or completely horizontal. And that should, with these sort of questions, that should be applicable a lot of the time, okay? when you're dealing with the movement of something around across the ground. If assumption meaning the ground would not be completely flat. But there we are. Okay, so I'm going to leave off with this exam question then. So we're given a curve has equation y is equal to f of x. We're given that the derivative f dash of x is 4x add a root x add b. Again, we've got a and b, they're just numbers, right? They're just unknown numbers, right? Don't be too freaked out about that. The curve has a stationary point at 4, 3, and the curve meets the y-axis at -5. We need to find f of x, okay? So it's the same sort of idea. We've got the derivative, we need to find f of x. But we've got some added information to find a and b, okay? But okay, so we're just going to start by integrating first, right, to get from the derivative to the normal function. So firstly, again, this root x is going to be a problem. I need to rewrite it as a power. So it's going to be 4x add ax to the half, right? Add b. Now I can integrate. So if I integrate, well, firstly 4x, that'd be 4x squared, then I'll divide by 2. So add 1 to the power. Then we have ax. Again, a is just the coefficient in the front, so just leave a where it is. Ax. Then x to the half, well, a half, add 1 to the power, we get 3/2. Then we divide by 3/2. Then b, well, b is a number, just integrates to bx. Okay, we add an x on, and then a plus c. Okay. Right, and we can kind of clean up the fractions a little bit. So 4/2 here goes to 2, so 2x squared. Then a over 3/2, well, the 3/2 is a fraction on the bottom, so we can kind of just flip the fraction to say 2/3 of a, x to the 3/2. Okay, add bx, add c. Okay, that's simplified. Okay, so now I need some information to find these missing values, a, b, and c actually. So firstly, we are told the curve has a stationary point at 4, 3. Okay, but this actually links back to differentiation. What does stationary point mean? If you recall, stationary point is where the gradient f dash of x equals 0. So we already have the gradient function, so we can set it to 0. So f dash of x, but what x is it? The point is 4, 3. So that means x is equal to 4, okay? So when x is 4, so if we plug in 4 here into my derivative, it has to equal 0. So therefore, if I plug in x as 4 into my gradient function, then my derivative, well, 4x is 4 lots of 4, add ax to the half, that's a lots of 4 to the half, add b has to be equal to 0. So then 4 times 4 is 16, 4 to the half is 2, so 2a add b equals 0. Okay, so that's that's one equation I have here. Okay, then we're told the curve meets the y-axis at -5. So that means the curve, remember the curve is f of x, okay? Here, the curve is f of x, not f dash f of x. But we just found f of x by integrating. So if the y-axis is at -5, remember the y-axis, so it looks something like this. Something like that, right? The y-axis at 5. So x is 0. So the coordinate is 0 for x and -5, sorry, not 5. It would look probably something a bit like this. There we are, at -5. Okay, so 0 minus 5 is my y-axis intercept, my y-intercept. Okay, that's what that's saying. So if it meets the y-axis at -5, the coordinate is 0 minus 5 because x is 0. So I'm going to substitute that in then. So f dash of f of 0. So I'm going to say at x is 0, f of 0 then. So that's my function at x is 0. If I substitute x is 0 into here, well, basically I'll get 2 lots of 0 squared as 2/3 lots of a of 0 to the 3/2, add b lots of 0, add c. Well, hopefully you can spot because everything apart from c here has an x. All of that goes to 0, so I'm left with just c. And I'm told the y-intercept is -5, okay? So that has to equal -5. So that means c equals -5. There we are. So now we can update our function. So f of x is going to be 2x squared, add 2/3, ax to the 3 over 2, add bx minus 5 for c. Okay, now we just need to find a and b. Okay, that's all of it. That's all the bullet points. But, and hopefully you did notice this, but, not only is this point a stationary point here, it's just a standard coordinate. That point also just lies on the curve, right? Not only is it a stationary point, but it's just a point in general as well. So we can substitute that point in as well, okay? So I'm going to sub the coordinate 4, 3 into f of x, because it lies on the curve. So that means f of 4, because x is 4 here, that's going to be 2 lots of 4 squared, add 2/3 of a lots of 4 to the 3 over 2, add b lots of 4 minus 5. So if I simplify these brackets, well, 2 lots of 4 squared, that's going to be 32. And okay, 2/3 times 4 to the 3 over 2 gets me 16 over 3. So 16 over 3a here. Then we have 4b minus 5. Okay. Okay. And I can then also do 32 take away 5. So that'd be 27. Add 16 over 3a. Add 4b. Okay, and then the f of x, the y is 3. So this has to be equal to 3. Okay. So then I can say 27 add 16 over 3a add 4b equals 3. And then I can take away 27 to both sides. So I get 16 over 3a add 4b equals minus 24. Okay, and that's my second equation. So, okay, if I then bring this first equation down, so then I'm going to get 2a add b, and then if I move this, down here, if I move this 16 to the other side, it will equal minus 16. Okay, so equals minus 16. Okay, it gets a bit confusing. Let me just relabel it as 1, 2. Okay, rather than 2, 1. Okay, there we are. Now these are just standard simultaneous equations, right? To solve for a and b. Now again, you can use your obviously your calculator has an simultaneous equation solver. And what I'd always urge a bit of caution when just stating the roots with your calculator rather than showing any working. I think the best way to approach stuff like this is to just do it yourself or show working, and then use your answer or use your calculator to check. Okay, you never know what the mark scheme will be like, but anyway, okay, so what I'm going to do to solve it, well, I can match, I could either match if I'm going to use elimination, I could substitute, that's fine, but if I was to do elimination, I need to match either the a coefficient, which is going to be quite awkward because we've got a fraction here and just 2. But b should be a lot easier to match. I have 4b on the first equation and b on the second. So if I just multiply the second equation by 4, I get 8a add 4b equals, well, minus 16 times 4 is minus 64. So then if I restate the other equation down here, 16 over 3a add 4b is equal to minus 24. What can I do here now to get rid of b? I can take away the two equations, right? So if I take away the two equations, well, 8 take away 16 over 3a is 8 over 3. A. Then 4b take away 4b goes to 0, as we intended. So then that will equal minus 64. Take away negative 24. That'd be a double negative, turn to a positive. Minus 64 add 24 is minus 40. Okay, so that means 8/3 of a is 40. So that means a, if I divide minus 40 by 8 over 3, I get a to be, looks like a 9, an a. So a would be minus 40 divided by 8 over 3 to get me minus 15. Great. So now I've found a, I could substitute a into either equation in my simultaneous equations. Let's substitute it into the second one here. That's a nicer, right? So I'm going to substitute a into the second equation. So that means 2a, that's going to be 2 lots of minus 15, add b equals minus 16. Okay. Again, to remind you, that's the equation we've got there. So then, to solve for b, well, simply 2 lots of minus 15 is minus 30, add b is minus 16. So then b, if I add 30 to both sides, 30 add minus 16, it gets me 14. And there we are. So therefore, in summary, a is a minus 15, b is 14. So, but that's not the question. The question wasn't to find the missing values. The question was to find f of x. And when it means f of x, to find it, it means to find all the missing coefficients. So we need to restate the function, okay, with all the values determined. So f of x then, if I remind you, f of x was this, 2x squared add 2/3 a, but a is minus 15, x to the power of 3 over 2, add bx, so that's going to be 14x minus 5. And so very slightly we can just clean up this bit here, multiply the bracket out here to get 2x squared, then 2/3 lots of minus 15 is minus 10, x to the 3 over 2, at 14x minus 5. And that's the fully simplified answer for f of x with all the coefficients found. There we are, okay? And that's it. So hopefully you get the idea now that we can go one step further. If we got some information, we can substitute that into the function to find any missing values, like plus c, okay? But yeah, so that's it. I'll see you next time.